So welcome. Welcome to those online as well. So my name is Brian Vanderwende. I'm in the CISL Consulting Services, and the point of today's presentation and then Q&A afterward is really to get folks up to speed on migrating files from tape. The fact that you're here means that you've probably seen the announcements we've put out saying that we are anticipating the end of life of the HPSS system in 2021. So we're trying to help people start early in migrating data off of tape and into other data holdings, and really examine their data profile and figure out what you want to keep and how to keep it. So the layout of this talk, basically, I plan to talk for about 30 minutes, and then the other 30 minutes, happy to work with folks if they have any specific targeted questions. Certainly, if there are questions related to any particular thing I present in these slides, feel free to just, speak up. I think I'll repeat your question because I think the room mics aren't live until the end. And if there are questions online, feel free to type them up, and we'll address those as well. But if there are any kind of broader questions, maybe save those until the end, and like I said, we'll do a Q&A then. And these slides and the presentation will be recorded, and they'll be online within a few days. So, the overall take-home message here is that the time to migrate important data from HPSS from tape is really now. So even though we're anticipating these dates in the future, so our high-performance storage system, HPSS, is going to go read-only on January 20th, 2020. So that's the soon date, and that's pertinent for workflows where you're still sending data to tape. Once it goes read-only, that won't be possible any longer. You'll still be able to pull data, and you'll be able to see data, but you won't be able to send new data to tape at that point. And then the end-of-life target is October 1st, 2021. So that sounds like a long way away, but it's really not that far. There's a lot of data on tape, as I'll show in a second. So these dates really are closer than they seem. A very important note here, this deadline will not be extended. Sometimes we have these kind of soft deadlines, and we say, this system is on its way out. In this case, it won't be extended. The issue here is that the vendor, Oracle, who is the company that supplies the tape drives that are used to actually read data on and off, or send data to tape and read data off, they've decided that they're no longer going to manufacture these tape drives. I think they've already stopped, and spare parts in the entire ecosystem for tape are in short supply. So this is a problem that's, it's going to build as time goes along, and by that October 1st date, we have to shut it down. Right now, the user community has 87 petabytes of data stored in HPSS. There are certain collections that we've been working to migrate to a different location, but by and large, CISL will not be automatically migrating any of these data. So the responsibility to preserve any data that you want to keep lies on you. And then part of that's by design. It's a way to kind of move on from this data that's sometimes been around for 30 years and nobody's looked at it. Sometimes it's been around for 30 years and people have been using it. So, some data makes sense to migrate and some data doesn't. But those decisions need to be made, kind of interactively and consciously. And the other message here is that of the tape drives we have now, each of them has a limited bandwidth, of course. So it can take quite a bit of time to migrate large data holdings. We've done some math, and we figured that if everybody wanted to pull all of the data from tape, it just couldn't happen. So there's really about enough time at this point to migrate 50% of that 87 petabytes before that end-of-life date. Based on communications we've had with the labs, it seems like there's probably about 20 to 30% of that data is still valuable and still scientifically useful for folks. So that's what we've been anticipating, and that's why we think that this overall situation is okay if people are proactive. But that's the key. So let's get right into the steps here that at least we're recommending people follow. So first off, a lot of the data on HPSS, perhaps almost all the data on HPSS are tied to large projects, collaborative efforts. So it's a good idea before you even jump in to form a migration plan with your team. If your project has a PI, talk to them and see what their plans are for the data. They may already have a plan. They may already be migrating data. So really what we're trying to avoid is we're trying to avoid duplication of effort here. And we're trying to especially avoid lost data. So work with the project PI to determine which data to save and where it will go. If you have access to some internal storage, NCAR internal storage, then that may be the location that it goes to. If you're a university user, or it's a university project, maybe it's going to go to some external storage. And we have guidance for each of those data paths. But the take-home message here is that the PI may already have a plan. So it's good to not just jump in individually unless they're truly files that only belong to you. Yeah, so coordination can prevent unnecessary and or duplicate transfers. And given that, that limited bandwidth that we have and the limited throughput we have on those tape drives, duplicate transfers, we really want to avoid those. And here's my little analogy. Think of the HPSS data drives as highways. So if we can keep more cars off of them, like US 36, then the more likely that everybody gets home before the next workday. If the planned destination is campaign storage, which, for those of you who haven't stepped into campaign storage yet, it's CISL's next generation cool archive for data. It's disk-based, so it's different technology, but the capacity is growing over time, and we've seen adoption pick up, I would say, over the past few months. You may need to request an allocation. You can see if you already are tied to a campaign storage allocation by running the glade quota command on the terminal. I'll show that right now, actually. So here I'm logged into Cheyenne. Can everybody in the room see my typing here? Okay, good. So if I run glade quota for myself, I guess that font is actually a little too big. But at the bottom here, let's make it a little smaller. There we go. So I have my spaces on Glade here, and then I have projects. And then at the bottom, there's a summary of the campaign spaces that I have access to and the usage on those. So it may be that you're already tied to a campaign storage allocation, and you haven't even gone on it yet. But you can get a full listing there. And they really are, the hierarchy of campaign storage is for the most part, it's project oriented. So that's what you should see there. But if you are internal and you can get a campaign storage allocation, but you don't currently have one, you can visit this link, or the PI can visit that link and get more information on requesting a campaign storage allocation. And that would be a very logical place for data that you want to archive to go, data that lives on tape currently. Also, if you just Google CISL allocations, that would be another way to get to it. Okay, so once you have a plan, then obviously the next thing that you need to do is to understand the data footprint that you have right now on tape. A lot of people have pretty sprawling collections of data that are located in different directories, and that can be tricky to track down. And of course, our concern is that we migrate all the data that wants to be kept off of HPSS, but ultimately the scientific concern here is not to lose scientifically important data. So getting an inventory is step one. So on HPSS, files and directories are associated with projects. And when you log into Cheyenne or Casper, you can get an idea of these projects by simply running the ID command, which is a Unix command. It gives you your user ID, your group ID, and then it gives you all the groups that you're associated to. Now, generally people are tied to more groups than they are tied to projects in HPSS, but any project that you're tied to in HPSS will be a user group here. So if I run this, I can, on myself, or I'm not sure, I guess NAD is the user. You can see that they're tied to two groups here. And those two groups are groups that files and directories on HPSS may be attached to. So, and that's a good way to kind of get an idea of the project structure of those files as well. You can also obviously go into sam.ucar.edu to see projects that you are tied to. Now, the way that some things are structured on HPSS, the project files may be in a dedicated directory, maybe like, for example, in this example, /CESM, but they could also be in personal directories, and just because of the nature of file sharing, there may even be some files that you care about that are in other people's personal directories, which makes things trickier. But you can get an inventory of directories that you know about and care about using the HSI interface itself. For example, you can run HSI ls -l capital R capital U and give it a path, and it will give you a recursive list of all the files that are in that directory and its subdirectories, and it'll tell you information like the project that it's tied to. It'll also tell you whether it's currently on disk or on tape, because the way HPSS is designed, files that have been used recently get moved to a disk cache so that they're faster to read. So those files can be retrieved more quickly than the files that are on the colder tape storage. That's kind of a more getting into the weeds, but it's kind of useful information to see when it's last been accessed as well. Now these inventories can be long. There are some directories on tape that just have tons and tons of files. So it's really best to redirect the output to like a text file that you can put on Glade. And this this redirection operator here will work for both Bash and C Shell. So let me demonstrate this one as well. So if I do HSI ls-lru on my home, now I'm not redirecting to a file here, obviously. I'm gonna have to make it a little smaller. Apologies for that. But here you can get an idea. It's pretty similar to the ls command, but you can see the POSIX permissions, the owner, the group, which in my case it's just an NCAR group, because these are my personal files. They're not tied to a particular Unix project, but the charging project that they're tied to is listed here in this column, and then I can see whether they're on disk or tape, and then of course the name. So this is a good way to get that list of files that it's in a directory that you know about. Now, if you have holdings that are spread over tape more broadly, that can be trickier. So we, CISL, can provide you with inventories of all the files that you own. For example, and we have these for every user on tape, so we can provide those at request. If you go to support.ucar.edu, which is our relatively recently launched ticket system, go to the research computing section and then submit a ticket asking for an HPSS inventory. Then we can provide that for you. And right now we have these inventories just for users, but we're looking at making inventories on a per project basis as well. And what we have right now is we have the file size, the project that it's tied to, and then the path. We may add things like last access time as well, just because we think that could be useful information for folks. But this will be across all of tape. So it's too long of a query to run interactively, which is why we don't provide that command right now for you to just fire off. But we have all that data, and we can share it with you if you have very spread holdings. Okay, so now I have an idea of the files that I have. What next? So really, rather than just jumping in and starting to pull data off of tape, what we recommend is that you organize the files on tape first. And the nice thing about this is, regardless of where the data is stored on tape, it organizes it into this kind of hierarchical disk system, and all that metadata is stored on a server. So you can, in effect, move the files around on tape, and it's essentially a free operation. If I move a file from one directory to another on HPSS, it's not actually moving it to a different tape. It's just changing where it's being pointed to. So you can leverage that fact to basically move all the data that you want to save into a directory, which will make it very easy to then run a get operation, a recursive get operation on that directory, and pull it to scratch or wherever intermediate location you're going to have it. So in this little example here, I'm basically saying, okay, I've got this project 0001. I'm making a directory in there on tape called the save directory. And then I'm moving various data that I want to keep into that save directory. And that's just going to make it easier on me because I don't have to have a lot of cget operations and worry about organizing those efficiently. My recommendation, or our recommendation, would be to create directories and use the naming of those directories to really label your migration effort in any way that's useful to you and any metric that's useful to you. So you could create a directory structure that's like a project, your intention for that data, this data I'm going to save, this data I'm going to delete, or a destination, this data is going to go to campaign storage, this data is going to go to external university storage or whatever. And then once you have that structure, it should be very easy to see, in a broad sense of what data you're going to have to move, how big it is. So you have some idea of how long it's going to take and how much storage you need in that other location. And again, the take-home point here is that organizing by directory allows you to use the recursive HSI commands, which buy you efficiency. Okay. So we kind of see there being three main migration paths for data. For a lot of internal NCAR staff, the expectation is that important data will probably go to campaign storage, since that's the next generation archive. For other folks, they're probably going to need to move it to external storage, be that at a university or some other lab, just because, Scratch isn't long-term and project spaces are almost always usually full. So we have guidance for those two data paths. So the campaign storage data path is really the simpler one, I suppose, since they're both internal to our authentication. Campaign storage is POSIX accessible, which basically means you can access it in a terminal on the data access nodes. So if you're not familiar with those, if you haven't seen these before, let me make this bigger again. So right now I'm on Cheyenne. If I run hostname, I can see I'm on Cheyenne 3. But I can do a SSH to dataaccess.ucar.edu, and now I'm on one of these data access nodes. These are virtual machines, so they're not designed to do any sort of intense computation, but they are designed to be to have access to all of our data storage platforms. So right now I'm still on Glade. I'm still in my home directory, but on these data access nodes, I can access Glade campaign, which gives you terminal access to the campaign storage archive. And then for me, I'm in CISL, I'm in the CSG group, and here I can see my personal directory on there. Now the thing about campaign storage is we've really moved the decision making in terms of the structure of these lab spaces to the labs. So your space may look different than this one, but that's a way to look at it and kind of get an idea of the overall structure of campaign storage very easily. When we launched campaign storage, it was only Globus accessible, but while Globus is a great transfer mechanism, it's not the best at navigating through a file system. So now it's accessible by the terminal as well. The other thing is those data access nodes also have the HSI interface, so you can do a direct get operation from tape to campaign storage. You don't have to park the files in an intermediate transfer on Scratch or anything. You can just move them in one step, which is nice. So the way this would work is you would go onto this data access nodes. you would navigate to a location in your campaign storage, maybe make a new directory, and then run an HSI cget operation with these two options to it. The -R to do a recursive copy. And then this -A, capital A, is really important. This tells HSI to order your recursive get by tape. And that's crucial, really, because otherwise the little like robot that HPSS has will have to go and like pull different tapes while you're doing your transfer if they're not in sequential order. This way you can get a tape, get all the data that you have on that tape off of it, and then move to another one, so it's much faster. And that's what organizing by directory really buys you. Because if you don't organize by directory, then you have to manually order the files that you're getting by tape, which is a kind of a laborious process. So leverage that -A option. It really is helpful. So here's a little example. So from Cheyenne, you can also access the data access nodes via any workstation or anything. You can sign into those directly, just as you would Cheyenne. So you don't have to go via Cheyenne. I'm just doing that in my example here. So I go onto those data access nodes. I make a directory in my campaign storage for my project. I navigate into that, and then I run my cget on my save directory. And that may take some time, but once that's completed, then all of that data in the save directory will be safely migrated to campaign storage. I may say this later in the talk, but one thing that I would recommend for these type of operations is to run them in a session program like GNU Screen or tmux or something like that. And if you're not familiar with those, basically, right now I'm in tmux here, but the nice thing is I can detach from this tmux session. Let me turn that off. I can detach from that tmux session, and it's going to run in the background, so that transfer that I have going will keep going even if I sign out of Cheyenne. And then when I sign back in, I can do tmux attach, and then that terminal session is still going. So that's a way to have those transfers run, even if you're worried about like your SSH connection breaking, or it's just so long that it's not reasonable to expect a terminal session to last that long. Now you can also submit these. We have an HPSS partition in Slurm, so you can submit a batch job basically that will run your transfer, and that also has access to both campaign storage and HPSS. That I believe has a 24-hour wall clock limit. So if your transfer can fit in that time frame, that's all well and good. But I personally recommend these data access nodes because there's no effective time limit if you have a session saving program running like this. And there are good guides on using Screen or tmux online, so if you're not familiar, then they're really quite handy, I think, for general work as well. Okay, so let's say you need to migrate files to external storage. The optimal way is to use Globus if the external storage has a Globus endpoint. So the nice thing about Globus, it provides a fast, robust, and traceable method for migrating the data, because all of those transfers that you run will be stored in Globus's remote database, so you can track the files that you moved and have a record of that. And also, Globus will restart the transfer if it gets disrupted for some reason. The thing about that, though, is there's no Globus direct connection to HPSS, so you do have to do an intermediate HSI get first. So first you would use HSI to get the files from HPSS and probably put them in a Scratch space. Scratch has a 120-day purge right now, so if the Globus operation doesn't complete in 120 days, then contact us, because that's a serious transfer. But then once it's on Scratch, you can use the Globus web interface, or you can use the command line interface to initiate transfers of the data that you've put onto Scratch to your external storage. Obviously, again, this assumes that you have an endpoint on that external storage. Like I know CU, for example, has a Globus endpoint. A lot of universities do at this point, national labs as well. Our endpoint is the NCAR Glade endpoint, and you can search for that on globus.org, and that would be your source endpoint for these transfers. Now, let's say you want to migrate to external storage and you don't have a Globus endpoint to use, then you're kind of back to relying on the command line utilities. So, the default ones would be like secure copy, SCP. rsync is nice because it won't copy, if you use the right settings, it won't copy files over that have already been copied. So that's nice. There's also a program that we used to, I think, push more before the days where Globus was really available, this BBCP command, which we do have available on our systems. The nice thing about BBCP is it uses multiple transfer streams. So if you have a good connection between the two locations, it's going to be faster than using SCP. The tricky thing with that is that it's a peer-to-peer program, so that the client, the program itself must be installed and in your path on both systems. But that's usually something that it's pretty easy to do yourself if BBCP isn't available on your external system. But for small transfers, probably using a secure copy is easy. It's a good way to go. And then if you have a really large transfer and you can't use Globus, then maybe spend the time to get BBCP working. Again, here I say it here, but if you use Screen or Tmux, you can run and track these long-running transfer commands. And here are just some examples. So, I have my intermediate directory on Scratch. I run my cget to get all the data off of tape, and then I can do a recursive secure copy to my university storage, or I can do a recursive BBCP copy to do the same. And this -A option is useful for BBCP because that tells it not to copy files that have already been copied. So it kind of works like rsync. Okay, so you've moved all your data. Now, obviously, you want to verify that the migration was successful, because if these are long-running transfers, you're probably not sitting at your computer monitoring them interactively. So when you're done, it's a good idea to verify that all the files that you expected to be transferred are there. So have an inventory, make sure the sizes are correct. If you want to get fancy, you can do things like checksums, which will make sure that they're bit for bit the same. But usually, these are pretty robust utilities, so usually just doing a file size inspection is good enough. And you can do that by ls queries. You can look at your Globus transfer logs. Globus does that. For certain transfers, it does that checksum verification itself. So that is another nice feature about Globus. And if the checksums don't match, then Globus will actually redo the file copy to make sure that it was a proper copy. And I would, when you run SCP or BBCP or any of those utilities, they almost always have a verbose mode. Usually it's a -v. So if you turn that on, then it will tell you for each step that it's doing, and you can redirect that output to a file and have that on record to inspect later on. So once you've spent the time and verified that the migration looks good, then the next step would be to contact the project PI. If you are the PI, then you make the call to approve to remove the files from HPSS. This is an important step for us. This helps us track the overall migration effort. And it also ensures for you that you don't transfer those files again. Maybe you're managing multiple projects, and once you get one project done, you can say, okay, let me get rid of that and then move on to the next one. So it helps to see what's going on. But for us, it's very important because we get an idea of whether we're going to hit that target of getting all of the user data off of tape before the end of life. But of course, remember to verify first, because data removal from HPSS is permanent. Deleted files aren't recoverable. This has always been the case, but in a large-scale migration like this, it's extra important. And of course, these are the recursive remove commands. The delete, if I create a directory to organize all the files I don't want, then I can easily delete them like that. And then once you've verified your migration, you can remove the saved ones as well. So this is kind of just a little flowchart of the overall process. So you have these preparation steps, coordinate with the PI, inventory your files, organize the files for transfer. Then you're going to do the actual migration. So there's maybe 3 different options here. You can migrate to campaign storage, to an external location via Globus, or to an external location via command line utilities. Now, again, this requires an allocation on campaign storage, this requires a Globus endpoint, and this just requires some remote storage. And then you're going to verify, review the data on the destination, and eventually remove the data from HPSS. You can remove if you do an intermediate on Scratch, you can remove that as well, or you can wait for it to purge off. And then here's just a summary of those commands that I've had in the other slides. So if you want like a kind of a take-home slide, this would be the one, and this will be in the distributed version of the slides. So I can even imagine like printing this out and having that as a reference. One last word regarding storing new data. So there's still some users who have workflows that are writing data to tape. We understand those workflows have been developed over a long time and can be hard to change. But again, tape is going read-only in January of 2020, which is certainly not that far away. So it's critical that you modify your workflows to store the data differently, starting now, really. Just an overall message, keep in mind that storage for us and for other HPC sites is becoming the bottleneck, not the compute power of the system. So evaluate really which data you need to keep and which data you could regenerate if you had to. With a lot of model data, this is more and more viable all the time. Obviously, with observational data, that's a different story. But the current lifespan on Scratch is 120 days. So this has been increased, I think, twice over the past year. So, consider just keeping files in Scratch if you expect to get your work done in that time. Obviously, if not, then make other accommodations. If you have an allocation on campaign storage, really the idea of campaign storage was for it to be a publication scale storage platform. So there is a 5-year lifespan for files on campaign storage. If you should get you from generating the data or collecting the data to publication. And again, campaign storage is available with standard terminal access on the data access nodes and also on Casper. That's a recent addition. And it's still Globus accessible on the Cheyenne, Login, and Batch nodes. Particularly with Batch, if you use these utilities that we've put together, this gcert and GCI command, that will allow you to use that in a Batch node, which lets you put it into a job workflow. The standard Globus command line interface isn't accessible on the Cheyenne Batch nodes because the Cheyenne Batch nodes don't have access to the internet. But this command will allow you to do that. And there's more detail on those commands at this link. Okay, so finally, just some suggested best practices. So take care to get files only a single time. Duplicate operations use valuable tape drive time, which hurts both you and the overall effort. So do your best to try to not duplicate transfers. In particular, if you do have holdings that are spread over tape pretty diffusely, you may have multiple copies of a file in different tape directories. So that's where getting that inventory is really useful. And creating that unified save directory, or whatever you want to call it, that you're going to do the recursive copy of, or the recursive get. Again, record commands and output from those commands into log files. Those log files shouldn't be that big. They shouldn't take too much storage. Odds are they'll just fit in your home directory. And you can always reference those moving forward to say, okay, did I get this file that I really care about? Was the transfer successful? Use verbose modes when available for commands. If you are still writing data onto HPSS, keep in mind that this will slow the migration throughput. We've had a couple of tickets from users saying, well, I'm writing data and the writing operation is really slow because I'm pulling all of this data. You have a concurrent transfer limit of 5 files at any one time on HPSS. So when you've got data moving in both directions, both things are going to be slower than you expect. So again, that really emphasizes the idea of modifying your workflows at this point to move your data somewhere else. And when in doubt, feel free to contact us for assistance. You can send us a help ticket or give us a call during business hours. This is I think some of the folks in our group have really spent a lot of time on this effort over the past year, really, at least. And we anticipate, dedicating a lot more time to it because, again, we recognize how valuable a lot of the data that people care about on tape is. So we want to make sure that you're able to get that off of there before tape does reach end of life. So, here's the getting assistance. You can go to our user support page if you haven't been there recently. You can do walk-ins. You can send an email here, but really going to that support.ucar.edu is the preferred method at this point for sending a ticket in. Of course, you can always call extension 2400 during business hours to talk with one of us. And if you have specific feedback from today, or if you have specific questions from today that come up later from this talk, feel free to send an email to me. That's my email address. And I'd be happy to try to help out. And there's a picture of tape just for sentimental reasons, the tape archive. So my plan is to stick around for until 10. If anybody has any specific questions about specific scenarios, feel free to come up to me and we can chat. But before I think we turn off the web broadcast, does anybody have any more general questions right now from the talk? And I should also say that what I presented today largely matches this migration website that we've launched. Let me bring that up here. So if I type in CISL HPSS, I can go to the HPSS page, and there's this banner up at the top here, which says users are advised to move or delete data from HPSS now. So if I click on that link, it will take me to a document that really kind of goes through the same process here. So you'll be able to reference this document and my slides and the presentation if you need. And if your questions aren't answered by any of those, then again, feel free to send us a ticket. Yes?
The slides are going to be available here?
So the slides will be on the website. They'll be in our course library. I'm guessing we'll send an email out to all the participants, right?
Yes, everyone who registered for this will get an email telling you when it's available and have a link to it. And it will also be announced in the daily bulletin when that's there.
Yeah. But I think if I Google course, yeah, it should show up on this page as well if you need to find it a different way. Yes?
There's a couple of remote questions. Can we use wildcards with HSI commands?
You can. So the question, I don't know if it came through on the mic, but the question is, can you use wildcards in HSI commands? HSI does its best to mimic a kind of a Unix terminal environment. There are certainly cases where it doesn't do that perfectly, like if you try to do a tab completion, it generally doesn't like that. But by and large, wildcards do work as you expect. I would suggest whenever you're in doubt about whether HSI will support some convention that you use on a regular basis, just do a little, maybe like 2 or 3 file test transfer. And if that works the way you expect, then you can use that on your large collection of files. Yes?
From another participant. This participant heard that projects at NCAR could purchase additional data storage from CISL at a rate of 45 terabytes per year, $45 per terabyte per year. But he wasn't sure. Can you confirm that this data storage is available? And let me know what the correct rate is.
That question.
And 2 follow-ups.
Okay. So the question was about purchasing additional storage from CISL at a certain dollar rate. So that's outside of my area of expertise. I would strongly suggest sending a ticket via support.ucar.edu, and we can get you pertinent information on that, whether that is the case or not.
The follow-ups to that were, can you also tell me anything more about this storage? For example, what will the interface and medium be for the storage?
Yeah, so again, for more information on what we offer, I would send in a ticket. That's not something that I deal with on a daily basis, so. Any other questions, BJ?
Not yet.
All right. Well, then, again, thanks for attending either in person or via the web. And if questions do come up, again, feel free to email me or send us a ticket. Thanks.